Alright, so one of the most basic things you need to know for curve sketching is about intercepts. And intercepts are exactly that. They're places where the curve intersects either one of your axes. So an x-intercept is where your curve crosses your x-axis. So where your curve crosses your x-axis, your function, say function f, will equal 0. Now where your curve crosses your y-axis, like here, will be a y-intercept. And that will be f, where your x is 0, right? So that'll be f of 0. So that will be some number, whatever. So those are your x and y intercepts. So how to find them is really the simplest thing to do. It's basically finding zeros. So if ever you're asked to find roots of a function or the zeros of a function or the x-intercepts, it's all pretty much the same thing. So say, let's go through an example. Let's say we have a function x and it's equals to x cubed minus 4x squared minus 4x plus 16. Okay? So to find out the x-intercepts, we have to find out where this equals 0. So we just set our function equal to 0. So how do we, this should be plus. So how do we do this? How do we find out where this function is equal to 0? Well, you could plug it in a calculator and you do zero's function, but the way you do this analytically is the way you do a polynomial analytically to find the roots is you factor it. So you can factor this using long division of polynomials, you can use synthetic division, or however you were taught. There are plenty of videos on YouTube of how to do that. But we're going to assume that you already know this. And if you don't, you can kind of pause the video right now and go to a video where you can teach that. It's a really simple skill. But basically, we're going to skip right to that part. And so after we factor this, we now know that this function equals x minus 2 times x plus 2 times x minus 4. Okay? It's the same function, only it's put in factored terms. 3 as the product of 3 binomials. So now it's easy to find the zeros of this, because if we have something times something times something, well, anything times 0 is 0, right? So if we can just find out where any one of these is equal to 0, then we'll be fine. So where is x minus 2 equal to 0? Well, that's easy. At x equals 2. Where is x plus 2 equal to 0? Well, that's easy. X equals negative 2. And where is x minus 4 equal to 0? Well, that's also easy. X minus 4 at x equals 4. So we know that f of x is equal to 0 at x equals 2, negative 2, and 4. So what does that tell us about our function? Well, that means if we wanted to graph it, we know it would, if this is our y, this is our positive x, well, we know that it has an intercept at x equals 2, right? So we'll have 1, 2. So it has an intercept here. Also has an intercept at negative 2. So negative 1, negative 2. So it has an intercept here. And then it also has an intercept at 4. So 1, 2, 3, 4. So, okay, so we know where our curve crosses the x-axis, but we need to know a lot more to be able to draw it. Because it could go like, because really, a curve could look like anything. It could look like that. It could look like that. It could look like that. Or like that. Or even something like that, where it's non-continuous. There are an infinite number of curves that could have these 3 zeros. So what we are going to do is we're going to learn just a little more. So what else could we know using intercepts? Well, we could try and learn the y-intercept. That could be helpful. So, well, how do we find the y-intercept? Going back to our beginning, y-intercept is where our function where x equals 0, right? So let's take our function f of x equals x cubed minus 4x squared minus 4x plus 16, and let's set it where x equals 0. Okay? Because our y-intercepts are where f of 0, where x equals 0. So that would be 0 cubed minus 4x squared, that's 4 times 0 squared, minus 4x, that's minus 4 times 0, plus 16. Alright, well, 0 cubed is 0, minus 0, minus 0, plus 16. So our function evaluated at x equals 0 equals 16. So that means, so what's that mean for our function? That means if we wanted to graph it, so our positive y, positive x, that we would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right here. And the curve will cross our y-axis there. And we also remember that it'll cross it at negative 2, it'll cross it at 2, and 4. Here, 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 and there. So that's basically how you do finding the roots of a polynomial. Now, let's go on to learn the roots of a rational function. Now, the roots of a rational function are exactly the same. It only looks different. So, let's keep our initial definitions of an x and y intercept, and let's look at a different function. So let's take some function x and set it equal, and have our function be x squared minus x minus 2 all over x plus 3. Okay? So, well, let's find our to find our x-intercepts, we set the function equal to 0. So, our function would be 0 equals x squared minus x minus 2 all over x plus 3. Well, what can we do to kind of solve for x? Well, we can multiply both sides by x plus 3. And what that does for us is, well, we can cancel these because we have an x plus 3 on the top and x plus 3 on the bottom. And then what's 0 times x plus 3? That's still 0. So x squared minus x minus 2. And we can factor that into x minus 2, x plus 1. Quick check. Negative 2 times positive 1, that's negative 2. Good. Negative 2 plus positive 1, that's negative 1. Good. So where is this equal to 0? Well, at x equals 2, this will be 2 minus 2, so that'll be 0. So this whole thing will be 0. So at x equals 2, and at x equals negative 1, at x equals negative 1, this is negative 1 plus 1, so this is 0, and that times 0 is, that's 0. So at x equals 2 and negative 1, our function has a 0. So just because this is a rational function, that doesn't mean the rules are any different. So all we need to remember, all we really need to look at is our numerator. Sometimes called n of x, our denominator would be d of x. So wherever our numerator is 0, we'll have our zeros, our x-intercepts. So, and same goes for y-intercepts. Say we want to find the y-intercepts of this function. Well, we just do f of 0, which is 0 squared minus 0 minus 2. So here we have 0 squared minus 0 minus 2 over x plus 3. Well, this will be 0 plus 3. Which will equal 0 minus 0, and that's 0 minus 2, so that's negative 2. And 0 plus 3, well, that's 3. So f of 0 is negative 2/3. Therefore, we have y-intercepts, or a y-intercept, at negative 2/3. At this point, you may think, wait, how can we get multiple x-intercepts but not multiple y-intercepts? Quick check. These are functions. And a function can only has to pass the vertical line test. So our y-intercept is a vertical line, right? So we can't have multiple points at our y-intercept. So that's how we use x and y intercepts to give us a general idea about our function.